So I'm just going to write that formula up at the top of my page. Probability of X outcomes for n experiments, choose X, is going to be the probability of success raised to the power of X times the probability of failure raised to the n minus X power. Then when I'm looking at these cases, it says if X is a binomial random variable, compute probability of X for each of the following cases. So for part A, I have probability of 1, because that's what my X is, equals, n is 5, so 5, choose 1. Probability of success is 0.2 to the X, which was a 1, and times Q. Now, if I know that P is 0.2, P equals 0.2, then Q must be 1 minus 0.2, or 0.8. So that's what I need in my formula, so I have to do 0.8 to the n minus x, and n is 5, x is 1, so 5 minus 1. And then I just simplify, combine things, put everything together. P of 1, remember, is just notation, just like function notation. It tells me the probability of exactly one success in, and then I have to look over here and see that my n is 5. So in 5 trials is this result that I'm going to get here. So 5 choose 1 is going to give me 5. There's 5 possibilities there, times that 0.2 to the first power, which is just 0.2. And then it's going to be times 0.8 to the, I can write it right up above, that's going to give me a 4. 0.8 to the fourth power is going to be 0.4096. And when I multiply all of those together, I get probability of exactly one success for this, for these 5 trials is going to be 0.4096. And this is how I would want to write my answer, because it tells me what my X was that I'm looking for on there. So I'll do another one. I'm looking to see what one looks hard. For part D, I want the probability of X is 3, so the probability of exactly 3 successes in my n is 5, so in 5 trials, so that 5 choose 3, times the probability of success for part D is 0.1, so 0.1 to the third, times, and then I need to know what my Q is. So remember, if my P is 0.1, then my Q is 1 minus 0.1, or 0.9. So that'll be times 0.9 to the 5 minus 3. That gives me a 2. 5 choose 3. Do that on your calculator. You get 10. And 0.1 to the third power, it's not going to change the 1, but it'll add some zeros on there, so it'll be 0.001. And then 0.9 squared is going to give me 0.81. When I multiply all those together, I have P of 3 equals, and that'll give me 0.01 times 0.81, so 0.0081. Pretty sure. Yes, so the probability for this experiment, the probability of exactly 3 successes out of 5 trials is going to be 0.0081. And remember, probabilities range from 0 to 1. And this is very close to 0, so it's very, very unlikely. This probability for part A was 0.4096, that's almost 0.5. So this was a lot more likely, part A, to have exactly 1 success out of 5 trials with this success rate of 0.2, and than it is down here to have exactly 3 successes out of 5 trials with a success rate of 0.1. So that's what we can see from there.